Okay, so now I'll summarize the key difference between the QTOF, QTOF, or LCMSMS. It's standing by triple quadrupole. So let's dive into it. The key difference between a triple quadrupole and QTOF. QTOF means quadrupole time of flight, lies in their ability to monitor multiple M over Z values. In triple quadrupole, M over Z values can be switched instantaneously, whereas in QTOF, they can be viewed absolutely simultaneously. In other words, triple quadrupole can rapidly switch M over Z values while QTOF steadily monitors all M over Z values concurrently. This concept is crucial for managing and assigning authentic compounds. Furthermore, in case where one peak is associated with multiple compounds having the same M over Z value, the MSMS spectrum in the library is used to identify the authentic compounds. Uh, Inspecting unlicensed or not approved drugs important aspect of is an important aspect of pharmaceutical quality control and regulatory compliance. It involves analyzing and assessing these drugs to ensure they meet safety, efficacy, and quality standards. This typically requires a combination of chemical analysis, testing for contaminants, and adherence to regulatory guidelines. Three steps using execute of MS with the IDA information dependent acquisition method. First, comparison with standard solutions. This is a common step by comparing the sample solution from doubtful products with standard solutions containing reference compounds. You can assess whether the sample contains any known pharmaceuticals, especially tonic or ergogenic substances. This helps in identifying potential contaminants or active ingredients. Second, comparison with accurate mass database M over Z. Analyzing the accurate mass M over Z of compounds in your sample and comparing it with a database of known compounds can help in identifying substances that may not be in your standard solutions. This can be crucial for detecting novel or unexpected compounds. Third, comparison with MSMS fragment patterns. MSMS fragmentation patterns provides valuable structural information about compounds. Comparing the fragment patterns of your sample with a database of known patterns can assist in identifying the chemical structure of unknown compounds. IDA versus SWATH in QTOF system. There are two different data acquisition strategies used in QTOF MS for comprehensive analysis. IDA, Information Dependent Acquisition. This is targeted approach used for known compounds identification. IDA is typically used for targeted analysis and compound identification. It is well suited for situations where you know the specific compounds of interest and want to detect and identify them in a sample. In IDA, the mass spectrometer first performs a survey scan to identify ions present in the sample. Based on predefined criteria, intensity, or charge states, it selects specific ions for fragmentation. These selected ions are then subjected to MS-MS analysis to provide structural information. IDA is efficient for identifying known compounds and is sensitive to low abundance analytes. It is commonly used in pharmaceutical, environmental, and forensic applications. SWATH. This sequential window acquisition of all theoretical mass spectra. This is an untargeted approach used for comprehensive profiling. SWATH is designed for untargeted or data-independent analysis. It aims to acquire data on all detectable ions in a sample, making it suitable for comprehensive profiling and quantification without prior knowledge of the analytes. In SWATH, the mass spectrometer divides the mass range into multiple small windows or segments. For each segment, it systematically collects data on all ions within that window. This results in a comprehensive dataset containing information about all ions in the sample, allowing for retrospective data analysis. SWATH is highly reproducible and enables the analysis of both known and unknown compounds. It is valuable for metabolomics, proteomics, and other applications where a broad overview of the sample is needed. The following paragraph is explaining about LC QTOF system and especially the Q in LC QTOF meaning. The distinction between LC QTOF and LC QQQ triple quadrupole mass spectrometry lies in their nomenclature, which can seem counterintuitive. In QTOF, the Q refers the quadrupole primarily responsible for ion selection and fragmentation in MS-MS experiments, followed by the TOF for accurate mass measurements. Conversely, in QQQ, triple quadrupole suggests a sequence of 3 quadrupoles, but in practice, one quadrupole filters precursor ions, another triggers fragmentation, and the third analyzes product ions. However, the similarity emerges in the function of the quadrupole in both systems. In QTOF, it selects ions for fragmentation, much like the second room of quadrupole in QQQ. This illustrates a conventional within mass spectrometry naming, where the name reflects established practices rather than the order of operation. In the execute of mass IDA information-dependent acquisition method, ions undergo a specific sequence: division at the LC column, ionization at the ion source, an initial surface scan in the TOF system, selection of ions meaning criteria in the quadrupole, fragmentation in the collision cell, and crucially, ions returns to the TOF system for precious mass measurement of fragment ions. In summary, while the naming conventions in mass spectrometry can be counterintuitive, understanding the function of each component clarifies their roles in both QTOF and QQQ systems, with the quadrupole in QTOF playing a role akin to one of the quadrupole in QQQ for ion selection and fragmentation.